Consider the series. Consider the case where the series is geometric. Show that p is plus minus 1 over root 3. If the series is geometric, hence there must be the common ratio, the same ratio, and the ratio is any term divided by the previous, and this value must be constant. The series to be geometric. Hence, let's consider the ratio, and it is equal to the second term divided by the first, so it's p ln x over ln x, and it must be equal to the third divided by the second, 1/3 ln over p ln x, and we can see that it becomes p squared is 1/3, hence p is plus minus root of 1/3, which is plus minus 1 over root 3 as required. The next, hence or otherwise shows that the series is convergent. Convergent implies that the sum to infinity exists, and the condition is given in a data booklet, and it says that the sum to infinity exists provided that the absolute value of the ratio is less than 1, and the series is convergent. It means that the infinite limit exists, and it means that the series tends to some specific value, not to infinity. So, hence, the required condition to be convergent is that the absolute value of the ratio must be less than 1. So, let's consider the absolute value of the ratio, and the ratio here is p, it's this, so it becomes the absolute value of plus minus 1 over root 3, and it's just 1 over root 3. Root 3 is greater than 1, hence it's less than 1 as required, and hence the series is convergent as required. The next, given that p is greater than 0, so p is plus 1 over root 3, and its ratio and the sum to infinity is equal to 3 plus root 3, find the value of x. The formula for the sum to infinity is given in a data booklet, and it looks like the first term divided by 1 minus ratio. Hence it becomes the first term, it's ln x, so it's ln x, 1 minus ratio, which is 1 over root 3, and it is given that it's 3 plus root 3, and we need just solve for x. We multiply both sides by this, and we can make here a common denominator, hence it becomes ln x is root 3 minus 1 over root 3 multiplied by 3 plus root 3, and we can factor out root 3, and it becomes root 3 plus 1. It is equal to, it cancels, and we can see that it's a formula a minus b, a plus b, which is a squared minus b squared, and it's just 3 minus 1, it's 2. And we need just undo this log, and log, for example, log 8 is 3, because 2 cubed is 8, and ln its log to the base e, hence it becomes e squared is x. So it's the required value of x. The next, now consider the case where the series is arithmetic with common difference d. Show that p is 2/3. If the series is arithmetic, it means there must be the same difference between two consecutive terms, so any minus the previous must be constant, and and let's consider it. So let's consider the second minus the first, and it must be equal to the third minus the second. So p ln x minus ln x, p ln x minus ln x must be equal to 1/3 ln minus p ln, 1/3 ln minus p ln, and it becomes 2p ln, and we can divide each term by ln, and hence we get 2p is 1 plus 1/3, so it's 4/3, hence p is 2/3 as required. Write down d in the form k ln x, where k is rational, so we need the common difference. It's any term minus the previous, so it's actually this or this, because it's the common difference. So d is p ln x minus ln x, which is 2/3 ln x minus ln x, and we can factor out ln x, and it becomes 2/3 minus 1, which is minus 1/3 ln x. The next, the sum of the first n terms of the series is, find the value of n. A formula for the sum of the first n terms of the arithmetic sequence is given in a data booklet, and it is equal to Sn is n over 2 2u1 plus n minus 1 d, and it is equal to ln of 1 over x cubed, ln of 1 over x cubed. And the right hand side is ln of x to -3, and we know the property that it's -3 ln x. This formula is given in a data booklet, so the right hand side it's -3 ln x, and it becomes n over 2 to u1. The first term it's ln x, so it's 2 ln x plus n minus 1 multiplied by d. d it's -1/3 ln x is -3 ln x. And we can see that it's 1, 2, 3 terms, and we can see that we can divide each term by ln x and multiply both sides by 2 and get n2 minus 1/3 n minus 1 is -6. And it becomes 2n minus n over 3 n minus 1 is -6. Multiply each term by 3 to get 6n minus, and open parentheses here, minus n squared plus n is -18. And we can see that the quadratic equation arises here, and we can multiply by -1 and get n squared minus 7n and minus 18 is equal to 0. We can apply the sum and product rule. Sum is minus b over a, so sum is 7, product is -18. So we can consider 2, 9, but minus, so it's -2 and 9, but n it's a number, it cannot be negative, so the solution is 9. So the required value of n is 9. And that's all for this question.